that okay, we have completed the crystal structure of cellulose. In detail, we have seen different type of the crystal structure of the cellulose. That cellulose 1, cellulose 2, cellulose 3, cellulose 4. Now, next point, that is nothing but the swelling of cotton fiber, or how the swelling of the fiber is taking place. It is there. Now, whenever you are talking regarding the swelling of fiber, see there are two types of the swelling is there. One that is intercrystalline swelling, and second that is the intracrystalline swelling. So intercrystalline swelling is restricted to the amorphous phase of the polymer. So whenever you are talking regarding the one polymeric chain or the whatever or the set of the polymer chains over there, in that I told that there are three different phases are present in cotton. That is a crystalline region, amorphous region, and mesomorphous region. Crystalline region is a region where polymeric chains are compactly arranged. Amorphous region is a region where polymeric chains are far apart from each other. And mesomorphous region is the region between the crystalline and the amorphous region. Now, why this particularly the intercrystalline swelling region is restricted to the amorphous phase only? It is there, and the intracrystalline swelling is a region penetrate in the crystals also. Now, Now, if you see the polymeric chains, as I told that in amorphous region, polymeric chains are apart from each other. And yesterday only we have seen the structure of the cellulose. In that, if you see whatever the crystalline region it is there, in a crystalline region, whatever the free hydroxyl groups are there. See, these free hydroxyl groups, they are forming the bond with the neighboring polymeric chains also because of the compactness. Whereas in amorphous region, in which whatever the polymeric chains are there, they are apart from each other. And this amorphous region, whatever the hydroxyl groups which are present over there, they are free in nature, it is there. That's why whenever the water absorption it is there, so whatever the water will get easily penetrate because of the openness of the amorphous region. And that's why intercrystalline, so within this particular polymeric chain, there is a immediate absorption of the chemical it is there. So in case of the intracrystalline swelling, the reagent penetrate the crystals. So whenever you are talking regarding intra, means it is penetrating inside the crystalline region also. So whenever you are talking regarding the cellulose undergo the swelling in a solution, so which are these chemicals in which the undergo the swelling? One in acids, second that is a bases, or we can say the alkalis, salts, and selected organic solvents it is there. In this, whatever the various reagents are there, whatever the cellulose it is there, that causes the swelling. Now, swelling power generally increases in order to, means lowest you will get the swelling in an organic solvent, then in a water, then in a salt solution, then in acid, and highest you are going to get in a basis. So simple example, I'll tell you, or during the practical also we have seen that the treatment of the cotton with a 5% NaOH or with a 17.5% NaOH or 17.5 to 22.5% NaOH. In all the cases, what is happening? What are the cotton fiber? It is that the cotton fiber swells. That during the practical also we have seen that when you are carrying out the treatment of the 5% NaOH with a cotton at a boil, we are going to get a swelling. Similar case, we have seen that when you are treating the cotton with a 17.5 to 22.5% NaOH, there's a swelling it is there, and because of which whatever the kidney shape or the bean shape cotton it is there, it get converted to the elliptical or the round shape it is there. So all this thing is happening because of the swelling it is there. So whenever the swelling is happening, there is one more phenomena which is happening that we have to take into consideration. Suppose this is our fiber. So whenever the swelling, and these are our polymeric chains are there. Now what will happen? Whatever these various solvents are there or the reagents are there, they will penetrate inside this. Now whenever there is a penetration it is there, what will happen? There will be the increase into the diameter of the fiber. But whenever there is an increase into the diameter of the fiber, what will happen? Length will decrease. So whatever, whenever the swelling which is happening, it is the radial swelling. This is called that radial swelling. Radial swelling is more as compared to the axial swelling. Axial means this particular swelling. Because of which there is a decrease into the length of the fiber. That's why whenever we are dipping the fiber in a water, it is there. See, the diameter of the fiber is increasing, and what is the length of the fiber it is there, that is a decreasing, because in this case there is a more of the radial swelling than the axial swelling. So this is a radius it is there. That's why this is called a radial, and this is a axis of the fiber, and whatever the to this axis we got the polymeric chains over there. That's why this is called an axial. So here we are going to get the radial swelling rather than the axial swelling it is there. That's why whenever we are dipping the fibers in such type of the solvents, the diameter is increasing but length is decreasing. And this you can easily notice, see, when you are carrying out the processing of the fiber, when you are dipping the fabric in water, there is a shrinkage it is there. Now why the shrinkage is there? Because of this particular nature only. But when you are dipping it in there, diameter increases but natural length will decrease. So inorganic intercrystalline swelling agents include the methanol is there, ethanol is there, then aniline, benzaldehyde, nitrobenzene. So these are the organic intercrystalline swelling agents. But I'm talking regarding this point. But they do not have that much effect onto the fiber. Whereas more of the effect we are going to get the bases or alkali. Alkali, and what is the difference between base and alkali? Yes, any one of you? Am I audible?
Yes, sir.
Okay, so what is the difference between base and alkali? Or both are same?
सेमच की काय डिफरंट असते
नाही असतो काहीतरी फरक आहे. I'm getting only answer from Vivek, Alok, Priyanka. What about other? There are 68 students are there now in a class. Now 55 students are present. Only few selected students are always giving the answer. Now from next lecture, what I will do, those who are, I will randomly take the name. If he or she is not in a position to give answer, I will remove it from the team only, not from that lecture, but from team only. Because you have to be attentive, because this part is not going to repeat it to you. And from next lecture, I am again. Yes, Ankush?
सर दोघी सेमच ना सर फक्त
नाही.
बेस बेस मध्ये डिटेल होत नाही आणि अल्कली होते
नाही नाही अंकुश क्लिअर नाही झालं.
सर अल्कली वॉटर सोल्युबल बेस आहे ना.
So what's the difference? Base and
Sir, base do not dissolve in water.
No. See, there is a thin light difference. Yes.
हॅलो
हा बरोबर आहे.
जे OH मायनस रिलीज करतात ते बेस असतात आणि अल्कलीज OH मायनस रिलीज करत नाही.
मग आता Na2CO3 तो पण अल्कली आहे.
Na2CO3 हो
सोडॅश.
तेच की Na2CO3 मध्ये कुठे OH मायनस
नाहीच आहे ना. मग NaOH हा
NaOH
हा
बेस
मग
आहे कारण तो OH
मग तो
मायनस रिलीज
अल्कली
करतो
नाही.
ना तो.
नाही मला सांग आता कुणाचा तर नॉइज येतोय. प्रियंका माईक म्यूट कर. See, NaOH is a base or alkali?
NaOH is base.
Base. It is not alkali.
Base.
Okay. Next, Na2CO3, it is a base or alkali?
Na2CO3 alkali असतं.
अल्कली.
Na2CO3 alkali, NaOH पण alkali. then
सर NaOH बेस राहणार ना.
NaOH बेस आहे.
okay,
NaOH बेस आहे सर.
okay, no, it is also alkali. See, a simple difference that, see, all alkalis are bases, but all bases are not alkali. The bases which are soluble in water, they are alkali. Got the point? The bases which are soluble in water, they are alkali. So NaOH, Na2CO3,
Sir, they
they
are
are.
interchangeable.
No. See, what I said, all alkalis are bases, but all bases are not alkali. The base which are soluble in water, the base which are soluble in water, they are called alkalis. So Na2CO3, that is alkali. NaOH, that is alkali. Why? NaSCO3, sodium bicarbonate, that is also alkali. Means they are bases, but they are soluble in water. That's why we are using the term as a alkali.
And NH3, sir?
NH3, ammonia is the water soluble. Water soluble. Again, that is a base.
Okay.
Liquor ammonia. We can have ammonia when you are purging in water. We can have the ammonium hydroxide.
Yes, sir.
Sir, then KOH.
That is also alkali. It is water soluble.
सर विच वॉटर सोल्युबल नसतात ते कोणते बेस?
ते तुम्हाला आता
Example.
लिस्ट. ओके, जस्ट वेट, आय विल गिव्ह द लिस्ट. तुम्हाला हे झालेलं आहे ना?
अल्कली आणि बेस मध्ये डिफरन्स एवढा माहित नव्हता सर.
जस्ट मिनिट.
नाही, ते पॉइंट आला नव्हता डिफरन्स.
तो सांगितलं ना. सी द बेसेस विच आर सोल्युबल इन वॉटर, दे आर कॉल्ड एज अल्कली.
नाही, मागच्या वेळेस आला नव्हता सर. आता तुम्ही सांगितलं ना.
नाही, मी मागच्या वेळेस नाही सांगत. मी तुम्हाला म्हटलं की हे सगळं ह्याच्यात झालेलं आहे की नाही, प्युअर केमिस्ट्री मध्ये.
हा सर.
हो
मी
सर.
ते म्हटलं.
झालेलं.
हा,
झालंय सर.
कारण हा पण झालेला असणार आहे. सगळे वॉटर सोल्युबलचे मला मी ते एक्झाम्पल दाखवायला लागले. NaOH वॉटर सोल्युबल, KOH झाला, मॅग्नेशियम हायड्रॉक्साईड झालं, परत अल्युमिनियम हायड्रॉक्साईड पण वॉटर सोल्युबल आहे. अमोनिया इज ऑल्सो वॉटर सोल्युबल. जस्ट तुम्ही पण चेक करा. क्युप्रिक ऑक्साईड एक येतं बघा, कॉपर ऑक्साईड. Copper oxide is an example. One more. Then magnesium oxide. These are the example.
Yes, sir.
Okay, so next, all this causes the less swelling. So whatever these inorganic solvents are there, sorry, not inorganic, whatever these organic solvents are there, just like a methanol, ethanol, aniline, benzaldehyde, nitrobenzene, they causes the less swelling than the water. So more of the swelling we are going to get in a basis, in a acid, then in a salt solution, water, and lastly that is the organic solvent. Now see how these things will help us. See when you are carrying out the processing, it is there. See during the processing, when you are dipping the fabric in water, only in water, you will observe that there is a swelling, it is there. But in that water, if there is a alkali is present, in that water, if there is a alkali is present, there you will observe that there is a tremendous shrinkage, it is there. See simple one process which you are going to perform, that is a mercerization, which you are performing at a concentration of 17.5 to 22.5% NaOH or 48 to 52 degree tolerance. In that, if you put the fiber, there is a tremendous shrinkage you will observe. The fabric will become just like a elastic rubber. Such much shrinkage we are going to get it. That's why whatever the mercerization it is there, we are carrying out in a taut condition. Taut means in a tight condition it is there. If there is a no any tautness or the tender it is there, again whatever the fiber fabric it is there, it will get shrink. Whatever the fabric it is there, the fabric will get shrink over there. Secondly, in acids. So again, when you are carrying out the processing, say few stages are there where we are using the acid, just like during the acid desizing, very rarely we are using, or when you are carrying out the neutralization, means after the mercerization is over, later on we are carrying out the neutralization at that particular stage also. In salts, means when we are carrying out the dyeing of the fibers, that might be a reactive dyeing or any other dyeing, we are using the salt as the exhausting agent. So during that particular stage also, there's a chances of the shrinkages it is there. So that you will get the idea when you are carrying out the processing. So in which stage we need to take more care as far this particularly the shrinkage is concerned. And more detail you are studying this point in a TOPT. TOPT 1, when you are studying the mercerization, these points will be clear too, where you can easily see the how the bean or the kidney shape is going to convert into the completely round shape or the elliptical shape. What are the changes it is taking place? Mathematically, you are going to study over there. So this is regarding the swelling. Then next point, that is nothing but the reactions of the cellulose. Now here see, now regarding this particular point, see this point is not limited only to the cotton fiber, but this is related to the all cellulosic fibers. That might be cotton, jute, flax, viscose yarn, polynogic yarn. In all fiber, this particular reaction is going to take place. So there are two types of the reactions which are taking place. The reactions which involving the hydroxyl groups. So wherever this particularly the hydroxyl groups are there, in that particular thing, what are the reactions which are taking place? And second, reaction compromising the degradation of the chain molecules. Means the reaction which causes the whatever the our long chain it is there, it will get breakdown, or wherever this particular ring it is there, that ring get breakdown, that particular reactions. So first we'll see today that is the reactions which involve the hydroxyl groups, and based on this whatever see now why this point is important over here, or why you are studying, because later on whatever the various modifications of the regenerated fibers which you are going to study, whatever our modified cellulosic fibers which you are going to study, or whenever you are carrying out the dyeing of the fiber, finishing of the fiber, or the printing of the means all whatever the processing when you are going to carry out. So all these processes where there is an involvement of the hydroxyl group, it is there, that point will be clear to you. So reactions involving the hydroxyl groups. Now, whenever you are talking regarding the cellulose, it is there. So this is our cellulose structure, which I showed you last lecture, and how to draw it. That also I told you. So again, I'm telling you that you just make a practice of writing or the drawing the cellulose structure, because as soon as you are making the practice, the things will be more clear to you. So over here, see whatever these OH groups are there. So the acidity of the hydroxyl groups increases in order. Now O6 and that OS6, OS3, OS2. Now, if you see whatever this cello bias unit it is there, in this cello bias unit, we got the glucose unit it is there. Now, whatever this glucose it is there, to this, as I told that we got this in a cello bias unit 1,4 beta glucosinic unit. So wherever we got this one, so this is one position, this is second position, this is third position, fourth position, fifth position, sixth position. So whatever these 6 carbons are there, they got this particular numbering. Now see the hydroxyl group which is attached to this. Hydroxyl group is attached to second carbon atom. Hydroxyl group attached to the third carbon atom, and hydroxyl group which is attached to the 6 carbon atoms. Means there are 3 carboxyl groups are there. Now out of this, see out of this, whatever this it is there, see, this is called a primary hydroxyl group. This is a primary hydroxyl groups, and these two are secondary hydroxyl groups. Got the point? Because this is a separate individual one. That's why this is a primary, and these two are secondary hydroxyl groups. Got the point? 3 hydroxyl groups are there in a glucose. Out of this, one we got the primary hydroxyl group, 2 are secondary hydroxyl groups, but whatever the reactivity order it is there, the reactivity order we are going to get more in a secondary, second position, then in a third position, then in a sixth position. Means whatever the acidity of these hydroxyl groups increases in order in this. So whatever this particularly the hydroxyl groups are there. Now again in that also there are different type of the reactions are taking place. Means reactions with the primary or secondary hydroxyl groups of the amorphous region only. Now again if you see here we got the crystalline region and the amorphous region. Now in amorphous region, as I told you that we got the pre-hydroxyl groups over there, whereas in crystalline region, there's a compact arrangement it is there, and there's a hydrogen bonding is there. So whatever these pre-hydroxyl groups, now we got the 2 types of the pre-hydroxyl group, that is a primary and the secondary hydroxyl group. Now that primary and secondary hydroxyl groups which are pre in amorphous region. So reactions with the primary or secondary hydroxyl groups of amorphous region only. See the difference. Primary reactions with both primary and secondary. What the difference? Primary or secondary means either this or this. That is the first case. Second, all this means both primary as well as the secondary of the amorphous group. Then the reactions with the primary or secondary hydroxyl group with the amorphous and the surface of the crystalline region. See, try to understand the points.
Hello,
Next, yes.
सर क्रिस्टलाइन स्ट्रक्चर मध्ये सेकंड आणि थर्ड नंबरचा जे हायड्रोक्सिल ग्रुप आहे ते पण हे होतात
नाही
हायड्रोजन बॉन्ड तयार करतात
सेकंड हँड हो ते करतात की
दोन्ही
हो 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 जे ज्याच्या जवळ
मग फक्त
जातील हा यस
अच्छा
हा
मग फक्त प्रायमरी हायड्रोक्सिल ग्रुप तेवढाच अवेलेबल असतोय का
नाही तोही करतो हायड्रोजन बॉन्डिंग जिथं जिथं जे ग्रुप्स जातील तिथं ते बॉन्डिंग करत राहणार हा so they're the primary and the secondary hydroxyl groups. Now see, just a minute. Now, if you see over here, see in a crystalline region also, see here what I'm talking, the surface of the crystalline region means suppose this is a fiber it is there. And here we got the crystalline region. Here we got the amorphous region. Now, we are talking regarding the reactions of the primary or secondary hydroxyl groups of the amorphous region. Means primary or secondary group or any of this, either secondary will be involved or primary will be involved. Then second type of the reaction, both secondary as well as the primary. Then third case is that primary or secondary hydroxyl groups of amorphous and the surface of the crystalline region. Means in amorphous region there will be the reaction of primary or secondary, but additionally whatever the hydroxyl group which are there on to the surface. So this is a crystalline region which I have shown over here. On this particular surface, whatever the primary or secondary hydroxyl groups which are pre over there, they will get react. I have not used the term in crystalline region, surface of crystalline region. Clear the point?
Yes, sir.
And next, that is a reactions of both primary and secondary hydroxyl group of uniformly both in a amorphous and a crystalline region. So these are the four different type of the reactions which are possible. Now, so all the reactions takes place without breaking the chain may have a local effect only. So whenever you are talking regarding the reactions involving the hydroxyl groups, now whatever these four possibilities which I told you, that primary or secondary of amorphous, primary and secondary of amorphous, primary or secondary of amorphous and the surface of the crystalline, primary and secondary of amorphous and the crystalline region. So whatever this particularly hydroxyl groups means you got the idea that where this particularly the hydroxyl groups are available. Now this hydroxyl group will undergo these are the different type of the reactions. So whatever these four different type of the hydroxyl groups which we got it over there, and or. So always remember or in amorphous and in amorphous means primary and secondary, that is common. Then or in amorphous and crystalline and in amorphous and crystalline. Likewise, I mean. So whatever all these four possibilities are there, reaction of the hydroxyl groups, they are undergoing this different type of the reactions. So you don't get confused between these four and these five different type. Means whatever these reactions of the primary or the secondary hydroxyl groups which are present in amorphous region, they may undergo the addition or replacement of the H in OH minus or nitration or alkylation or the oxidation. Any of this particular reaction they will undergo. So these reactions involve the hydroxyl group can be as follows. So either we can have the addition reaction, either we can have the replacement of H in from the OH group, esterification, which involve the nitration, acylation, and the nitration, etherification, that is alkylation or the benzylation reaction, and lastly that is the oxidation. So these are the five different type of the reactions which are possible with all these types of the hydroxyl groups. Now, whenever these reactions are taking place, here, whatever the reaction it is taking place without breakdown of the chain. So first, that is the addition reaction it is there. So in presence of the selected chemicals in a restricted concentration, various tertiary compounds formed between the cellulose, water, and the chemicals present. Example, cellulose from the cellulose. So, okay. I'll show you over here one more. You can check it over here. See cellulose, and here we have used the NaOH over here. So whenever the cellulose, so while writing the short form of the cellulose, it is written like this, cell OH. This is a short form. You'll find it in the books also. So while writing, it is written like this. So this particular thing, whatever the cellulose it is there, it is reacting with the NaOH. And whenever there is a reaction between the cellulose and NaOH, we are going to get the soda cellulose formation. Likewise, when you are carrying out the treatment of the cellulose with the KOS, potassium hydroxide, what we'll get? We'll get a potassium cellulose. Lithium hydroxide, we'll get the lithium cellulose. Ammonium cellulose complexes over there. So whatever the ammonia, we know that it got the NH3, so that it will get react everywhere, and we can have the ammonia cellulose complexes over there. So where this particularly the reactions will take place, or the which are the I will use the term in our processing stages, these reactions are possible. That point I will tell you now. So these hydrates are able to penetrate inside the both crystalline and the amorphous region. Now, whatever this addition reaction it is there, this addition reaction is taking place in the both crystalline as well as the amorphous region it is there. These hydrates. Now, soda cellulose formation, where this thing is possible. So one, that is during the maceration, part of the cellulose might get converted to the soda cellulose. Secondly, during the manufacturing of the viscose rayon. So this is a first reaction which is happening during the manufacturing, that first we have to carry out the purification of the cellulose. Then whatever the cellulose which we got it there, this cellulose we have to treat with 17.5 to 22.5% NaOH. And whenever you are carrying out this particular treatment, whatever the cellulose it is there, the cellulose will get converted to the soda cellulose. Now this is a required reaction. This is a required reaction. Cellulose we need to convert to the soda cellulose. Now why we are converting it into the soda cellulose? Now based on this you have studied one reaction. Organic chemistry, in one of the practical you have performed the sodium fusion test. I think you have performed.
Yes, sir.
Yes, sir.
Why you are carrying out this test?
For detecting nitrogen, sulfur.
Now why this particular
Hydrogen.
test? Hydrogen, okay.
For detection of elements.
For detection of iron, that's okay. But why test with the sodium metal only? Why you are not selected any other metal? See, iron was also there easily available, but you are taken that is everyone's favorite reaction. Na? You are taking the sodium, you are carrying out the fusion, then you are adding the compound, you are heating it. Then whatever
Yes.
whatever the sodium fusion test it is there, you are putting it in a water. In a dish, you are taking water and you are putting it in a water. So whatever the filtrate it is there, that filtrate you are collecting, and that filtrate you are using for the testing purpose. Now, why to carry out this particular test? See, directly you can take the compound and you can perform the test.
सर
Yes or no?
सोडियमची ऍक्टिव्हिटी खूप जास्त आहे.
Yes, who said this? Sohel?
सोहेल
Sohel. Yes,
सर
exactly.
सोडियमची ऍक्टिव्हिटी खूप जास्त आहे, त्यामुळे सर आपण जर एलिमेंट्स डायरेक्ट घेतलो तर सर त्यामधनं एलिमेंट्स डायरेक्ट आपल्याला वेळ लागणार कुठले कुठले एलिमेंट प्रेझेंट आहेत घ्यायला. मग
Yes,
सोडियम
exactly.
बरोबर फ्युजन होणार, मग ते लवकर आपल्याला करता येईल.
Exactly. See, what we are going to get. See, sodium salts are water soluble easily. Second, they are highly reactive in nature. That's why what we are doing, we are converting into the sodium salt. So similar way over here, what we are doing, whatever this cellulose there, we are converting to the soda cellulose, so that further whatever the reactions which are going to perform during the manufacturing of the cellulose, that is the xanthation, one of the reaction which you are going to perform. So where you are carrying out the treatment with the carbon disulfide. Now this CO2 will not react easily with the cellulose. So what we are doing, we are converting to the soda cellulose so that the rate of the reaction will be faster at a later stage, and we can carry out this reaction at a lesser time. So that the aim behind this to convert this particular thing during the manufacture. But during the processing, see, one more thing is happening. Whatever the cellulose it is there. See, in a cotton also there is a hemicellulose is also present. Very less quantity. Whatever the things are there, it is written in other. Hemicellulose is nothing but the our low molecular weight cellulose. It is there. It is just like oligomer. So this hemicellulose also get dissolved in a NaOH. That is also another purpose. That's it from the plant. From plant, we are going to get the cellulose, hemicellulose, lignin, all these things. We are going to get it. But whatever this hemicellulose it is there, this hemicellulose get solubilized in a 17.5 to 22.5% NaOH, so that whatever the cellulose which we got it later on, that will be the purest form will be there. So at this particular stage, that is a treatment with the NaOH, the our hemicellulose get dissolved, and we are going to get the soda cellulose over there. Then second type of the reaction, that is nothing but the replacement of the H in a OH. Replacement of the hydrogen from the OH group it is there. So which is this chemical?
Urea, sir.
Yes, it's a urea.
Urea.
So when you are carrying out the reaction of the cellulose with the urea, no, actually we are not carrying this particular reaction is happening at one more stage, and that I will tell you that when the cellulose get react with the urea, we are going to get the cellulose carbamate over there. Cellulose carbamate, and there is evolvement of the ammonia gas is there. Now where this particular reaction is taking place. So in third year, you are going to study the finishing, and in finishing, you are going to study the resin finishing. And in resin, we are using urea formaldehyde resin, melamine formaldehyde resin. So out of this, what are the urea formaldehyde resin it is there? One of the resin is that commonly used DMDHEU, that is a dimethylol dihydroxyethylene urea, which we are manufacturing by using this urea also. That is one of the raw material is urea. So in that, if there is unreacted part, it is there. Unreacted part of the urea, it is there. It will get react with the cellulose also, and we are going to get the carbamate formation. It is there. We are going to get the carbamate formation over there, which is a unrequired
sir.
reaction. Yes.
सर the CONH2 पाहिजे ना कार्बामेट मध्ये.
हो, मी तर काय केलंय आर परत आणि आपल्याला मिथाइल ग्रुप्स असतात ना पुढे रिॲक्शन, म्हणून मी फक्त तुम्हाला हे दाखवण्यासाठी एवढं ठेवलेलं आहे. म्हणजे बेसिक कुठले रिॲक्शन होते ऍक्च्युली असं फ्री फॉर्म मध्ये नसतं तिथं युरिया. त्याच्यासोबत आधार पण बाकीचे पण इन्ग्रेडियंट असतात, म्हणून मी तर R2 दाखवलं, नाही तर इथं ते बरोबर आहे तुमचं, इथं H पाहिजे.
NH2.
You can R replace, you can H or the methyl group also. So मग इथं H घ्या चला, NH2. But again that will be the carbamate only. So whatever this carbamate it is there, that is actually the unrequired reaction during the resin finishing. Actually our requirement that whatever the resin which is there, this resin must react with the cellulose, but whatever the three groups are there, just a minute. sorry. Then see, so we are up to the point that whenever you are carrying out the resin finishing, see during this resin finishing, whatever the dimethyl or dihydroxyethyleneurea, whatever the resin it is there, it is our expectation is that it must get react with the cellulose only. But whatever the unreacted part of your during the manufacturing, urea it is there or the formaldehyde it is there, they will remain as it is in a solution. And that will get react with the cellulose, and there is a chances of the formation of the cellulose carbamate it is there. Next, that is a regarding the reaction of the cellulose with the sodium hydroxide that already we have discussed. So this particular reaction, see, it is coming in both the categories. That here we are replacing the hydrogen with a hydrogen with a sodium. So this particularly the replacement, as well as there is an addition we are doing of Na. So that is a sodium soda cellulose formation. It is there. So this particular reaction is falling in the both the categories. Then third reaction, which involves, that is a esterification. So that is nothing but the nitration reaction, acylation, and the xylation. So where these particular reactions are taking place, that point we'll see. So esterification is generally carried out in a strong acidic media. So first, whatever this nitration it is there, the nitration is taking place, the reaction with the nitric acid, which gives us the nitrocellulose. So this is the first regenerated cellulose, actually the nitrocellulose. Whatever the regenerated cellulose it is there. So first regenerated cellulose, actually it is a nitrocellulose it is there, which you are going to get the reaction of the cellulose with the nitric acid, and we are going to get the nitrocellulose. Second, that is nothing but the acylation. So whatever our cellulose acetate, cellulose triacetate reaction, this fiber manufacturing process it is there. In this, whatever the cellulose acetate is an ester of the cellulose and acetic acid it is there. So there will be the reaction between the OH groups of our primary and the secondary hydroxyl groups, and we are going to get the cellulose acetate. That is again actually instead of using the acetate, that is actually the diacetate it is there. And whatever the cellulose triacetate it is there, in a cellulose triacetate, whatever all three OH groups are there, these all three OH groups are replaced with the acetate group. So CSCCOO. So COO, that is we are going to get the ester linkage over there. So that's particularly the acetate reaction. And next, that is nothing but the xanthation reaction it is there. So the xanthation reaction is an intermediate reaction for the regenerated cellulose fibers like a viscose rayon and the polynosic rayon. So whatever the reaction which I told you, that is a sodium cellulose formation it is there. That is a sodium cellulose, not soda cellulose formation it is there. So soda cellulose formation reaction. Later on this soda cellulose, we are carrying out the treatment with the carbon disulfide. And this reaction is taking place in a primary cellulose. Whatever the xanthation it is there, it is taking place only in a primary cellulose it is. So whatever the soda cellulose which is formed over there, CS2C, this CS2OH, so CS2ONA it is there, where we are going to get the addition of the carbon disulfide, and we are going to get the xanthation reaction it is there. So this reaction I will show you while studying this our regenerated fiber, that is nothing but our viscose rayon manufacturing stage. So xanthation is happening during that particular stage, and it is called an esterification reaction. Again, over here, see whatever this all these three cases, we are not disturb the polymer chain. Only all these reactions are taking place in a hydroxyl groups only. Then next, that is a esterification. So that is alkylation of the benzylation it is there. It is a benzylation OS. So esterification is carried out in alkaline media with the alkyl halides or less commonly alkyl sulfates it is there. So cellulose is first treated with the alkali before esterification reaction. So that is nothing but the soda cellulose formation it is there. And then you have to carry out the esterification reaction. So for esterification reaction, the hydroxyl group of C2 is the most reactives in the most acidic nature. At this reaction we are performing in an acidic condition. That's why, in alkaline condition. That's why it is highly acidic in nature. That's why it will get reacted with the C2. So cellulose ethers are mostly thermoplastic in nature. And examples are methyl cellulose, ethyl cellulose, carboxymethyl cellulose, hydroxyethyl cellulose. Where you studied this? Have you studied these chemicals? Methyl cellulose, ethyl cellulose, carboxymethyl cellulose. Yes.
No, sir.
You're not
No,
studying
sir.
sizing. Sizing.
Sizing start केलं.
Sizing start केलं. Okay. See in
Start
sizing,
केलं.
whatever the additives which are used, additives. So one of the additives that is nothing but these are the additives are there. That carboxymethyl cellulose, which you are going to get it by the etherification of our cellulose only. CMC. You might be heard, this is also used in the food industry. That is a thickening agent. Custard powder. That is a CMC, and that is a edible. It is there, so that we are going to get the very thick custard, and that is because of the carboxymethyl cellulose only. And here, what is the CMC? That is a slightly creamish powder. It is there. It is again water soluble. So this CMC we are using as an adhesive in a sizing also. So these materials are used as a dispersing agent in emulsion. Even we are using the textile finishing to have the step finish. In a printing, we are using as a thickener for the printing. Whenever you are carrying out the printing, so to hold the print paste onto the fabric, we need to use the thickener over there. So that's why to have this to hold these particles onto the fabric, whatever the thickener which is used, that is one of the thickeners is the CMC. It is there. Even we can use as the adhesive also because it's got a good adhesivity. We are using as an adhesive in a sizing thickness. That is for the in a food industry also we can use it, or in a printing also. So these are the various applications of our etherification groups. Okay, so today we'll stop here because next point, whatever it is there, that is oxidation, it will take more time. So today we'll stop here.